Okay, so now when you evaluate this, okay, so you have but in the power of 1. So if you multiply 1 by n, what you get will be L to the power n. Remember the rule: when the power is raised to another power, you multiply the power. Similarly here, you have -1. When -1 is multiplied in the n, you have -n. So I'll remove this because I've already expanded. Similarly here, when you raise this power L, you mean the power 1, so you multiply that 1 by m as a rule of powers. You have 1 times m, which is m, so it will be L to the power m. But when you multiply a power of 0 in the m, what you get is always 0, because you say when you multiply a number by any number by 0, the number reduces to 0. So you have L to the power 0. Now, using also the rows of indices, when the bases are the same, when you are multiplying numbers with the same base, you add the powers. When you multiply numbers with the same base, you add the powers. Now, here we have the same base, L and L. So when you multiply the power, when you multiply these bases, L and L, you add the powers. So you maintain the base and you add the powers. So here you add n plus m as my powers using my rows. So it will be n plus m, n plus m. Similarly, for the base t, its power is -n and 0. So if you multiply, you'll be adding the powers. So it will be t to the power -n plus 0. So -n plus 0, you'll be getting the same -n. So to the power negative n. So t to the power -n. Now, amanena kuti ma powers omwe ma laws of indices, amanena kuti in an equation where you are dealing with my exponents, when the bases are the same, the powers also needs to be the same. So here we have a base of L, which is the same. We base uyu are in the power of 1, pamene uyu are in the power of n plus m. So if this base is equal to this one, then 1 should be equal to n plus m. So 1 should be equal to n plus m. So we call this as equation number 1. Similarly, for the other one, which is t are in the power of -1 to the left hand side. So this -1 should also be equal to the other power of t in the right hand side, which is -n. And when you evaluate this one at the end, you'll be finding that when you evaluate it, then n will be equal to 1. That's just cancelling the negatives. N equal to 1. Substituting substituting 1 for n in equation 1. Okay, in equation 1, and equation 1 in the pamene pali n. Oh, here we made a mistake. Let's come back here. It's -2. So L to the power -2 here should be L to the power -2. Okay. So t to the power negative 2 or t to the power negative 1, so we say negative 2 is equal to negative n, then n equals 2. So dalakwisa apa daikapo negative 1 molo motenga formula imene ili kuyika negative 2. Okay, so substituting 2 for n in equation 1, then what you get is 1 equal to, pamene pali n pakhala 2 plus m, 2 plus m, meaning kuti m will be equal to negative 1. So 2 akapita the other side azikakhala negative, so 1 minus 2 will be equal to negative 1. Now in our equation, the original equation, remember the original equation timanena na kuti a acceleration equal to v to the power n r to the power m, and tapeza na kuti the value of n equal to 1, the value of n equal to 2, and the value of m is equal to negative 1. That's what we found out. The value of m equal to negative 1 and the value of n equal to 2. Now to find the equation, what you do, you substitute in this one. Pamene pali n muyikapo yani 2. So where there is n you put 2, where there is m you put negative 1. So where there is m put negative 1, meaning this is now an equation for centripetal acceleration. So I'll just put a subscript c to define what we are dealing with. It's not just acceleration, but it's a centripetal acceleration. So what we are dealing with is the centripetal acceleration. So this one currently subscript. So centripetal acceleration A is equal to that one. If you want to write that equation, you can also rewrite the equation as the centripetal acceleration equal to k as a constant, k v squared over r, k v squared over r. Remember mana kuti mwakauri mundi r to the power negative 1 imakauri it's a reciprocal of a value, makauri it's 1 over r. That's why tili ndi formula yotere. So this is a formula for centripetal acceleration. If you go into your books, you find the same formula for centripetal acceleration. Maybe what would differ is only the value of the value of k. So that's how we use the dimension analysis to find an equation. Yeah, that's the end of the lesson and also end of topic. I'll send an assignment on a group imene mugwenera kuti muchite. Thank you.